So we have a question, a very beautiful question, that if z is a complex number and the conjugate of z is equal to z, that's only possible if z is a real number, and vice versa. If z is a real number, then the conjugate of the z is equal to z. Okay, the complex number. Okay, so we have to prove it in the both ways, in the forward ways and the converse ways. So for the solution, we are given that is given if we consider that we are given with the value that z, excuse me, if we say z is equal to z, z conjugate is equal to z, that's given, and we want to prove that z is a real, and to find or to prove, we have to prove that z is real. So to prove that, how we are going to prove this? Okay, so to prove it, let me consider z is equal to a plus b iota, and uh, we are given that z conjugate is equal to a minus b iota, and it is given that z is equal to, z conjugate is equal to z. Now if we put the values, that is a minus b iota, which is equal to a plus b iota, in this case this a will cancel a, so what we get, we will get minus 2 b iota is equal to 0. Minus 2 b iota is equal to 0. This will give you b is equal to 0 by minus 2 iota. This will give you b is equal to 0. Now by using this in equation 1, so this implies that it means z is equal to a plus 0 iota. This will give you z is equal to a, which is a real number. This implies that z is a real. As we know that in any complex number, that a represent a real part, so it means that if z conjugate is equal to z, then z is a complex number. So if that's given, then z is a real number. Now we are going to prove it conversely, that if z is a real, then we have to prove that z conjugate is equal to z. For that, let me erase it. So now the converse proof is that if z is real, if z is real, then what we have to prove? We have to prove that z conjugate is equal to z. So for the proof, what we are going to consider? We are going to consider let. Now as we are given that z is real, excuse me, z is real, this implies that z is equal to only a. Okay, if z is equal to a, it means that the conjugate of z is equal to a, since a can also be written as a plus 0 iota. So the conjugate of a plus 0 iota is equal to a. So now if we take a look from this one as equation 1, let me write it here. Z is equal to a, and z conjugate is equal to a. So if I consider it equation 1 and 2, then from 1 and 2, this implies that z is equal to z, z prime is equal to z, or z is equal to z. So this is our required result, which we were going to prove. Okay,